analytical test for halogen compounds. Aromatic halogen compounds may contain halogen atom directly bonded to an aromatic ring like benzene, or halogen atom may be attached to a side chain such as in benzylic halides. Halogen atom directly bonded to one of the benzene ring carbon atom is called nuclear halogen compounds. Halogen atom is directly bonded to benzene nucleus. Hence, they are called nuclear halogen compounds. Halogen atom bonded to the side chain are called side chain halogen compounds. They can be easily distinguished by using a silver nitrate. Compounds like chlorobenzene do not give the reaction due to partial double bond character of carbon-chlorine bond. There are two tests for distinguishing nuclear halogen compounds from side chain halogen compounds. They are, first one, the given halogen compound is heated with a solution of silver nitrate in ethanol. If a precipitate is obtained, it indicates that the given compound is a side chain halogen compound. That is, halogen atom is bonded to side chain. From the color of a precipitate, halogen atom can be identified. If the color of precipitate is white, halogen will be chlorine. If a pale yellow precipitate is obtained, it indicates the presence of bromine. Yellow precipitate indicates the presence of iodine. Side chain halogen compounds like benzyl chloride dissociate in alcohol medium, forming halide ions. This halide ion react with Ag plus ions present in silver nitrate to form silver halide. Silver chloride is a curdy white precipitate soluble in ammonium hydroxide. Silver bromide is a pale yellow precipitate partially soluble in ammonium hydroxide. Silver iodide is a yellow precipitate insoluble in ammonia or ammonium hydroxide. So from the color of a precipitate and its solubility in ammonium hydroxide, nature of a halogen atom in the side chain can be predicted. Nuclear halogen compounds like chlorobenzene do not dissociate on heating with alcohol. Hence, they do not give a positive test on heating with alcoholic silver nitrate. Another test to distinguish nuclear halogen compounds from side chain halogen compounds involves heating of a halogen compound with dilute NaOH for about 15 minutes. After cooling to room temperature, the mixture is acidified with dilute HNO3 and then a few drops of silver nitrate solution is added. If a precipitate is obtained, it indicates the presence of side chain halogen compound. That is, a given compound contains halogen atom in the side chain. If no precipitate is obtained, it indicates that the given compound is a nuclear halogen compound. Here also the precipitate is due to the formation of a silver halide. Hence, from the color of precipitate and its solubility in ammonium hydroxide, nature of halogen can also be predicted. That is, if a curdy white precipitate soluble in ammonium hydroxide is obtained, then it indicates the presence of chlorine. A pale yellow precipitate partially soluble in ammonium hydroxide indicates the presence of bromine in the side chain, and yellow precipitate completely insoluble in ammonium hydroxide indicates the presence of iodine in the side chain. Nuclear halogen compounds do not give this test. In order to illustrate the chemistry of a reaction, suppose benzyl chloride is given side chain halogen compound. On heating with aqueous NaOH, it undergoes a nucleophilic substitution reaction to form benzyl alcohol and NaCl. This NaCl reacts with silver nitrate to form silver chloride, which appears as a curdy white precipitate. The precipitate of silver chloride completely dissolves in ammonium hydroxide. The purpose of acidifying the reaction mixture with dilute HNO3 is to remove unreacted NaOH if present in the medium. Otherwise, NaOH react with silver nitrate to form a curdy white precipitate of silver hydroxide. HNO3 is selected for acidifying the mixture. HCl, H2SO4, acetic acid, etc. cannot be used as they give corresponding silver salts which are insoluble and white in color. That is, acids like HCl, H2SO4, acetic acid, etc. gives white precipitate of silver chloride, silver sulfate, silver acetate respectively. Hence, nitric acid is used for neutralizing the reaction mixture. In the case of nuclear halogen compounds like chlorobenzene, nucleophilic substitution reaction does not take place. We know that due to partial double bond character of carbon-chlorine bond in chlorobenzene react with NaOH only under conditions of high temperature and high pressure. Therefore, on heating with dilute NaOH for 15 minutes, there will be no reaction, and hence no precipitate is obtained in this test.